Hello, I'm Etto, and today I'm going to interview the HyPower Rocketry team of the University of Bristol. Could you start by introducing yourself?
Hi, my name's Lillian.
My name's Ben.
I am HyPower Bristol's team lead this year, project managing the wider team.
And I'm working on the head of aerodynamics, so working on all of the external aero and fun bits we've got.
So our team story kind of is that we were founded in 2020 during lockdown in university halls in our first year at University of Bristol. Our mission really has been to build rockets and to learn lots whilst we're doing it.
So how's the university?
So University of Bristol is a city uni situated in the southwest of England. I study civil engineering, which in the UK encompasses buildings, bridges, foundations.
And I'm studying aerospace, which Bristol competes quite nicely with some of the other unis for the sort of top aerospace degree in the country.
In our courses, we have quite a nice blend of hands-on practical unit. So in civil engineering, that looks like field methods. And if you choose to do industry placements in your summers, or if you choose to do a year out, then you get to have some like practical applications. But there is also a lot of learning how to be a safe engineer, sitting in classrooms and crunching the numbers. The city that we are in, Bristol, is a lovely city. The next one up from, if you've got London, is the biggest in the south. Bristol is the up and coming city in the south. It's a really beautiful city to get to live in. We're very lucky to live here.
Yeah, it's also got quite a lot of nice aerospace heritage. So you've got Airbus nearby, and there's photos of the Concorde going over the Bristol Clifton Bridge, as well as Brunel did loads of work here. So Bristol is definitely steeped in heritage from that perspective.
Is the university free, or do you have to pay to go to the university?
In the UK, you do have to pay to go to university. You can get government loans to help you pay for university. In a different way to the rest of Europe, university is quite expensive in the UK. Yes, we do differ from the rest of Europe in that way, but it is accessible for everyone because you can use government loans to help you. And that includes both tuition fees, which you pay to the university in order to pay for your course and pay for the resources that you're using, and then also the living cost.
What are your job opportunities after you finish your university?
With aerospace, it's pretty much whatever you want to do. You'd struggle to cross into the civil domain, but aerospace really is a form of mechanical engineering. So you're learning the same principles that you would at mechanical engineering, and that means you can go anywhere from rocketry to like designing some of the ducts that are used in manufacturing plants. You could also look at any form of energy generation. So there's quite a big push here for sustainable energy. So that would be looking at maybe wind turbines if you're focused on aerodynamics, or you could also within the aerospace degree focus more on hydrogen generation.
For civil engineers, we can either choose, if you stay within engineering, a lot of people choose to not stay in engineering. But if you choose to stay in engineering, you can either go down the consultancy route, or you can go down the contractor route. So consultancy is about design, that's about EuRoC standards, and that's kind of a lot more office-based. And then contracting is a lot more site-based. So when you see engineers in high-vis and they're setting out works, that's what the contracting side of things looks like. From an engineering degree, we can also choose to pursue the space sector. Usually in the UK, that looks like pursuing a little bit of more further education, as the University of Bristol degrees aren't set up directly towards space as some of the UK universities have. So this looks like educating yourself a little bit more on the space sector, and maybe kind of starting and getting experience in another field that you can then take to the space sector, whether that is in civil engineering and having a better understanding of what construction looks like, in order to then look at, okay, what happens if we're terraforming on the moon, or what happens if we need to set up launch sites. So I would say that there are lots of opportunities. If we're looking at space, then the space industry very much likes to have more experience and knowledge, because it is such an engineering challenge. So to come at it fresh as a graduate can be quite challenging.
Should also add as well, where the space industry is quite immature in the UK. Basically, that means no matter what type of engineering you're doing, you can pretty much go into the space sector. So that makes it really nice. And there's a load of jobs in there at the moment. There's a lot of funding towards it, which makes it quite an exciting prospect.
What are your team's goals?
Our goal for this year is to enter the UK competition Race to Space with a liquid engine. And we are also developing some launch vehicle technologies to go along with that, which is quite exciting, and kind of having a look at what that looks like. When we talk about our long-term goals, we're really looking at inspiring passion for space within the University of Bristol. The space units, the optional units within the aerospace degrees at University of Bristol are very highly sought after and much loved by the students here. So being able to provide an extracurricular bit of space for people to get to do is an incredible thing that the Bristol EuRoC Space Society does here at Bristol, and we very much enjoy being a part of that and getting to look into rocketry in our spare time. So that's why this year we've expanded the size of the HyPower team. Those who have seen any of the media output from EuRoC23 will know that we were quite a small team of 6. And we have scaled up to, we're getting on for 35 this year, which is amazing because that brings even more people onto our journey.
And so you're already developing a liquid engine?
Yes, in the process, designing for manufacture, a regen liquid engine. Propulsion team are working very hard on this. We're very excited to see this come off, as it's a new field for Bristol EuRoC to be looking at. And so it's very much been a learning curve. We're very grateful to everyone we spoke to at EuRoC23 who gave us lots of information on the challenges that we might encounter, and we are encountering challenges. It's no mean feat to design a liquid engine. I'm trying to make that a bit of a reality.
You're probably going for a nitrous oxide ethanol engine?
Yes, we are. Although we might burn IPA in the UK competition because of availability. Propulsion team chose that because it's a bit of a standard across teams in Europe, and it seems to give us the thrust that we're looking for.
Fuels, it's quite nice to work with in terms of it's not like hydrazine. You're not going to end up having to put like a 3 kilometer boundary around working on this engine, and also it's got some quite nice properties and decent specific impulse, so that's why we've gone down that route.
What can members learn from joining your team?
Possibly on a actually broader note, part of, and maybe it links back to the last slide, part of our aims this year really are to put in the groundwork so that we've got good training for future years. So we don't want to make the mistake of when the team of us that have been working since COVID leave, there's then not the knowledge within the team to keep passing down. So really this question is actually quite topical for this year, because that is what we are currently working on, is building that up. From an aero point of view, we're looking at getting them to use rocketry analysis software such as OpenRocket and RocketPi, but then also looking into FEA and CFD, but then having the awareness of the difference between doing some hand calculations or using these tools and where each of those are valid and where you should be implementing them. So it's quite an exciting time really, because we're learning a lot of these tools from the aero side, as well as then teaching some of our 35 members those tools.
How do you design your rocket?
It's very iterative. It's definitely not a linear process. It's something that we've been coming to terms with since first year. It's very nice to think about, okay, well, if we work out, what apogee we want to reach, and then maybe what we want to make our rocket out of, and what propellant source we might want to use, and therefore what aerodynamics we need, and do we want to include a payload? And you think that those questions kind of come sequentially, and unfortunately they don't. You end up hopping between those questions, and as different things change. So the concept kind of comes from, what engineering challenges do we want to face? That's what gets us excited about rocketry, is that that it is a challenge, but then being sensible in choosing which of those challenges we actually take on. So that kind of defines our concept. You said concept to launch. There's a lot of steps within there, but that then comes with weighing up the how much money do we have. That often comes into it, because we're quite a small rocketry team. Doing a cost benefit analysis of the different elements of the rockets. Maybe this is, the propulsion team might be asking for something, but actually the launch vehicle team can't support that decision, and so we'll have a to and fro. So yeah, the process is it jumps around a lot, and it requires really good communication between our team members, which we're very lucky to have. And then we can get on to building some things and testing if they're structurally sound. Hopefully not testing to failure. That's our preference, because then that starts getting expensive. But then, so we, once we start getting into the build phase, then we are really looking at, is design safe, and is it holding up to the theoretical engineering choices that we made? And if we can say yes to enough of those safety choices, then that's when we're ready to launch and end up with the final product.
How do you measure the performance of your rocket?
We collect flight data from our flight computers, and if they match our simulations, that tells us what the performance of the rocket has been. We haven't had the chance to test a propulsion system yet, and I think that this consideration is going to be much more critical for us this year, because that will give us a much, when we talk performance for solid rockets, we're very much looking at the kind of hard flight data of the apogee achieved, and then did it perform the recovery operations at the altitudes that we're expecting? Whereas this year, looking at our propulsion system, and are we getting the thrust that we're expecting? Are we having the pressures and temperatures through our system that we're expecting? Those are some of the kind of concerns that we have this year, and that's the kind of data that we're looking to get.
How's the experimental rocketry community in the UK?
It's growing for sure. Which is really, really exciting. An amazing effort called Race to Space, which is a competition based around designing hybrid and liquid engines and test firing them on a stand, which is really pioneered by some at the University of Sheffield, which is really pushing the experimental rocketry community in the UK, and it's really incredible to see. In a couple years, it's going to start to get really, really exciting once that, because we're very much in a learning phase and just finding things out at the moment. Once we can start getting more teams more knowledgeable, the propulsion avenues that rocketry can take, I think that will make rocketry even more exciting in the UK. The future of the space industry in Europe looks bright. I know that there's definitely a push within the UK to put funding into the space industry, and there is absolutely the appetite from students to work in that sector. On the back of that propulsion competition that's happening in the UK, yes, we are in touch with other rocketry teams, particularly in the UK. We're lucky enough to go up to University of Sheffield a week ago, and we got to meet up with some of the other rocketry teams going for this propulsion competition, which was really amazing. And the knowledge share that's happening there, and the enthusiasm for the challenge of propulsion and for the challenge of space was really, really exciting to see.
One of the nice things as well, so the UK government has just invested a good amount of money into the space sector. One of the things that Lily mentioned, the learning curve, you might think that, well, rocketry's been done in many countries for a long time now, but because launch vehicles especially are quite heavily tied to the defence sector, actually trying to get information out of a different country that's much more advanced than, let's say, the UK is quite hard. So really, the UK is learning things from first principles, having to set up, having to publish papers and develop knowledge and build that knowledge from ground one, instead of just being able to look to, let's say, America and go, well, what have you guys done? How have you done it? So that makes it exciting, but also it does mean we've got some catching up to do.
How do you promote your team? We
promote our team through Instagram and LinkedIn, provide good interaction with other teams and members of the rocketry community. So they work for us, and it's quite nice for us to get to document our journey on these platforms, which is, we're very much are kind of looking forward to being able to share the rest of our HyPower Bristol journey.
What are your experiences at EuRoC?
EuRoC was incredible. Somehow got into EuRoC23. We launched a solid COTS to 3 kilometers we were very excited to be there, and we learned a huge amount. It was a really incredible experience. We were very enthused by the technical evaluation board. Being able to have industry professionals challenge us on our engineering decisions that we made on our rocket was a really great experience. We really quite enjoyed our flight readiness review. And if we were to do it again, we have some different things that we would change, and it's given us a more critical eye. When we look at other rocketry projects, we're asking those same questions that we got asked, and really understanding that testing is king. The importance of being able to evidence that that the choices you have made are safe and that they're going to fly, and that it fits within the rest of your system.
What were the biggest challenges you faced while developing your rocket for EuRoC?
The fact that we weren't all living in the same city at the time made it quite a challenge. So last year, the 6 of us, we were all on a year in industry, which is a choice that you can make at university in the UK. So you can take a year out of your studies to go and work in a relevant job, and you write reports on it. But it meant that we were hundreds of miles from each other, literally, and communicating over video calls and text messages. So we're very much enjoying being able to sit in the same room this year and just chat about rockets. I think that was really challenging, because as exciting as rocketry is, if you have no one to bounce it off of, it can get it gets a little bit lonely to be designing rockets on your own in a room. So yeah, we're really grateful to all be back in the same room this year. I think the build challenge, we did have a bit of a challenge with funding last year, in that there wasn't much of it, which we are very excited to see the future of the Space Society at University of Bristol just grow and grow, and we're hoping that future years won't have that problem of funding. But yeah, that meant that we had to make some choices on how many cameras and how much data we could have on the system. It was kind of hard getting the rocket to Portugal from the UK. Other UK rocketry teams choose to drive their rocket down. We didn't really have the facilities for that last year. We will definitely be doing that next year. But we put a rocket in the hold of a plane, which is technically okay, because they're completely benign. But that did mean that one of my teammates got pulled off of the plane to explain what was in that box that looks like a very suspicious shape to be putting on a plane. So I think that's a bit of a challenge, that there is the English Channel in the way between the UK and Europe, and we would definitely look at crossing that body of water in a different way in future years.
What are your goals for EuRoC?
We'd like to get in again. That would be really nice. That's our current goal. Our current goal is to apply for EuRoC24 and see if we can get in. It was an incredible experience. It really was. And to get to talk to all of those other rocketry teams who were so knowledgeable and so willing to share their knowledge, it was a real privilege to be at. Our objectives are to push the Bristol rocketry community, and that involves this year trialing a liquid engine on a test stand and seeing where that goes. But yeah, I think we have a lot of respect for the EuRoC competition, that it is of very high caliber, and to get into the competition itself is a challenge. So that is our current goal.
Would you like to join other competitions apart from EuRoC?
If someone would like to pay us to go to Space Cup America, we will gladly take and launch a rocket. We would absolutely love to do that. It sounds amazing. And again, that's an even wider body of the rocketry community. You're then looking at the global rocketry community, which is amazing to interact with through the global Discord. To get to go to a competition and meet some of these other teams would be incredible. But at the moment, the funding at University of Bristol means that Spaceport America is probably not on the cards in the near future.
You should also mention that in the UK, there's the MAC competition. Now, we don't attend that because we've got other teams within SEDS that go to UK competitions, and there's already one that's entered into that. So we don't want to tread on their toes and have 2 teams from Bristol competing. But the MAC competition's really up and coming, and they're doing some really interesting things. So that's one of those competitions to look out for in future years.
How do you think rocketry will evolve in the future?
I think in the UK, as we've sort of already hinted to, there's a lot of change coming. So the UK historically I mean, we've had the Black Arrow program, but that didn't really go anywhere. So really, we're just linked with ESA, and that's kind of been broken in the past few years. So it's really actually trying to, in the UK, set up that base for not just space exploration with satellites and that sort of thing, but also for actually launch vehicles and getting to space. You've got loads of companies, you know, you've got Skyrora, Orbex, Virgin Galactic, all that are in the UK, and where they're startups, they can do some quite interesting things. You know, much like SpaceX, when they started, they did the interesting thing of trying to land. So possibly those companies can bring a fresh perspective space industry. And it's really exciting to see where it will go. Hopefully we can form some stronger ties with Europe and continue to sort of work with them. And, you know, you never know, we might be on Mars by the end of the century. So,
could you provide more information about your rocket?
Overarching project we're calling Project Holocene. It's unique within our small rocketry community at University of Bristol, because currently we don't have a project name. We don't have a rocket name. Our goal is to develop some new technologies at University of Bristol for rocket construction. We really enjoyed the material performance of composites, and we're looking to kind of take this further. Our rocket last year was composite, and actually all of our rockets have been composite, and getting that you get very custom results with composites, right? If you can make your mandrels, then you can make your rocket whichever shape you want that to be. And we've had rockets that have a diameter of that, and all the way up to the last one from EuRoC. So this one is unique that it's bigger than other rockets that University of Bristol have built. And we're really looking to kind of see how that project evolves. Our sponsors so far this year, got to absolutely give an honourable mention to Rocetry UK. They've really made this project possible, as well as Shell and the Satellite Applications Catapult for their support in our project this year.
Probably say there are some exciting things coming from our rocket, but you'll have to wait to see those rockets go up before we can let you know what those are.
How much of your rocket do you build yourself, and how much do you outsource to sponsors or buy?
Launch vehicle will absolutely be made in-house. For some of the more critical elements, we look to outsource those. For the propulsion system that we're trialing this year, we would not be looking at making our tanks, and the Satellite Applications Catapult have been kind enough to offer us a 3D printed engine, so that's being outsourced. But we consider hands-on manufacturing in the University of Bristol to be really valuable, and it also means that we can provide very custom tailored results to the exact project that we're working on. The critical elements where there's very important safety margins involved, such as propellant tanks, we're not looking at manufacturing those yet, because we have lots of other engineering challenges to be getting on with. But we do absolutely value that hands-on build of the launch vehicle, as I think it gives a kind of real respect for the project that you're working on.
We're quite lucky at the University of Bristol because we've got a really quite impressive machine shop. So we've got something called a hack space, which is where as students we can go and manufacture stuff, and that's got, you know, drills and 3D printers and laser cutters, all that you can use. But also if you want something that's a bit more high quality, some quite impressive CNC lathes, etc., in the machine shop with some really good specialists in there that can get our tolerances down to some pretty impressive levels.
What software do you use to design the engine?
For the engine, I think most teams, especially in the UK, use this. It's RPA. Yeah, that's kind of the godfather of software for preliminary and initial designs of rocket engines. In terms of the rocket, there's a whole host of things. So we're looking at using Star CCM, which is a CFD software. We're looking at using Patron Nastron, which is a FEA software. And then we've also got some in-house codes that we've built to do some either initial sizing, but also some more detailed analysis.
Do you develop your own electronics or do you buy them?
We do develop our own electronics. We're working on more SRAD boards this year. We flew an SRAD board last year. It wasn't our main flight computer. It's more of a test of concept. But yes, we're looking at developing more electronics for the rocket this year. For that, we are requiring custom circuit boards. those are tested by our electronics team to validate their efficacy.
They've probably got the hardest job on their hands trying to get the electronics working. Basically, every single section of the rocket interacts with the electronics. So, and most of those electronics are flight critical. So getting those to work and work seamlessly and fast at a decent budget, that is really quite a challenge. And yeah, our electronics team and Lawrence are doing a fantastic job on that.
What type of recovery system do you use?
In the UK, it's a lot more standard to use black powder charges for your recovery system. That's generally standard within the UK rocketry community. I think that it raised some eyebrows in Europe, slightly less traditional with some of the European teams. But it works for us, and that's the method that we'll be looking at using in our future rockets, because it's reliable, and we're happy to use that. Dual deployment system at EuRoC23 works really well, and we were really pleased with that, and it meant that we got to fully recover both our rocket and our payload, which for us was a real highlight of the competition.
What is the payload of your rocket?
Payload last year was telemetry, so it involved a camera pointing downwards and taking a series of photos that we can then post-process. And that's looking at scientific experiments that might need access and good visual data for that's kind of what our payload last year was for. We're looking at kind of developing that on this year, and also we'd really like to get some externals involved in our payload this year. We've got some real estate in the payload canister that we would really like to be able to maybe fly something that a school or another university has developed, but that's still a work in progress for us.
The background to our payloads for 3 years now have been sort of camera based, and you might argue, why don't you just use a drone, especially for the heights that you're going to? But actually there's a lot of scenarios where drones aren't applicable. So originally that was looking at sort of mountain rescue in mountains, well, in mountains obviously, but there you've got really high turbulent flow, a lot of gusts, a lot of thermals, and it can be long distances, which a drone just isn't going to do. So basically where this all stemmed from was, how do you actually deliver possibly a drone, but how do you get it closer to your target? And then last year was, I believe, similar with looking at glacial.
Mm-hmm. Yeah, glacial research was the kind of pioneer for our payload last year. Which again, using rockets there is useful because of the atmospheric conditions you're going to have.
Does your team have any announcements to make?
We would love to make some announcements, but we want to be secure in our choices before we make them.
Do you have any advice to young rocketeers?
Give it a go. Get on OpenRocket. Watch videos on YouTube. Maybe you make a cardboard rocket. All of those things. Just have a go. I think that particularly within kind of outside of the rocketry community, when you talk about rockets, people assume that you're talking about NASA, and they don't realize that there are so many steps of rocketry between zero and NASA, and that you can get started whenever you like. Obviously, there are some requirements as to if you want to start buying rocket motors, but in terms of having a read, maybe like read Chris Hadfield's book, like have a look out there at what it is that about space that might inspire you. I think that if I could tell young people something, it would be that rockets aren't just something that NASA does. You can start having a look into it yourself.
The really exciting thing about the space industry as a whole is it's not just one industry. If you say space industry, you think, oh, that's just space, but actually, as we mentioned earlier, with basically any form of engineering being involved, but also you've got biology, chemistry, physics, you've got finance looking at, can you start making money out of asteroids, which, there's questions about whether we should be doing that, but any sector on the UK pretty much applies in space, except at a more extreme and possibly more interesting level. We had a fantastic talk at Bristol from Jim Green, who worked at NASA, about planetary science, and it just really opens your mind and, to what can be done. So watch as many YouTube videos as you can and just try and stay inspired and yeah, go from there, see what happens.
What are your favorite space YouTubers or space movies?
My favorite space movie has to be Arrival. It may be slightly Earth-based, but I just think that's an absolutely fantastic movie. And I think that it proves that point that space is wider than the concept of space is wider than what we think it is. It's about communication, and it's about like the human pursuit of greatness and challenge. Arrival has to be my favorite movie. Favorite YouTuber for me has to be BPS Space. I think he's great. Also you're amazing, but I absolutely love BPS Space. He produces some really great stuff, and really it's a really great education as well. And even if you're starting from ground zero, so back in 2020 when I started on the internet, how do I get into rocketry? BPS Space, I could start watching even when I knew nothing, which was really, really nice and accessible.
Yeah, I mean, in terms of YouTubers, I'm the same. BPS Space is like your bread and butter of not just the basics, but all the way up to doing some really quite impressive things with rockets. And to be honest, I think we were quite lucky. We kind of started getting into rocketry as he was a little bit developed, but he was still kind of growing, and we really got to watch his journey of learning as we were sort of a step behind learning on our journey of rocketry. In terms of movies, I mean, it all started with Star Wars, so I've got to give a shout out there. But also, I love The Martian. That's a fantastic movie, and the book is amazing as well.
Do you have any questions for me?
What gets you excited about rocketry?
Well, I guess that rockets are interesting. I like mostly the propulsion of the rockets, and I think the most interesting is liquid.
Have you had any go at building a liquid rocket engine?
Well, I have made some very simple liquid rocket engines in the past, mostly using my 3D printer.
Mm-hmm.
Nice.
A simple liquid rocket engine is still not simple engineering, though. That's a very impressive feat. No, that's really exciting. What excites you about the future of the space industry?
Well, yes, maybe currently one of the planned missions, which I think is most interesting, is the Artemis mission from NASA. I think that's quite interesting. But for the future, I guess that it would be very interesting to see, for example, asteroid mining, even though maybe that would be quite in the future, maybe space bases.
It's quite a nice project that was recently, well, maybe it wasn't recent, maybe I only came across it recently, but to my knowledge was recently announced, and that was trying to reduce global warming on Earth. And they were suggesting, I don't know how feasible it is from a structural point of view, but basically putting effectively a massive umbrella in space to basically reduce the amount of solar radiation we get from the sun. And I think within 2 years, they suggested you could reduce the temperature by 2.7 degrees Fahrenheit, which that's quite impressive. So yeah, that's quite a nice one. And what are your plans for the future in terms of rocketry, this channel? What have you got anything exciting there?
Well, I don't know what I will do in the future. Well, I guess that predicting the future is quite hard. So I'm not sure what I will do.
Apply to University of Bristol and come and join our team.
Yeah, are you okay?
I don't know what was that.
Someone's just tried to launch a rocket and it's not gone well.
Yeah, that sometimes happens when rockets tend to work very well. Mostly with the liquid rocket engines. They're probably the least safe.
Yeah, we are aware that they are quite hard. But we're gonna give propulsion systems a go. And we're really lucky to have the Race to Space platform to do that on, and that also provides some testing facilities as part of the competition. Yeah, we're going to give it a go, but we are aware it is very, very challenging.
In this Race to Space competition, is it like really a competition where someone wins for having, for example, the highest ISP?
Just to clarify, sorry, so Race to Space is a little bit misleading. It's actually only a engine test, so there's no speed of the rocket.
And also competition is a bit of a strong word for it as well. Really, the competition is against the challenge of building an engine and being able to successfully fire it. There's lots of UK universities taking part, like some doing hybrid engines, some doing liquid engines, and there's also a range of propellants happening within those. But yeah, the term competition makes it's a good word to use for it, but doesn't quite describe the amount of community and knowledge share and inter-team help that's actually going on. Because it is, like you said, it's quite challenging to make a liquid propulsion system work, and so really that is the competition is, can can we make this happen? So yeah.
It's more like a challenge.
It is more like a challenge. Yeah, just linguistically, the word competition.
It's really nice to see as well. Some teams seem to be challenging themselves a lot more than we are. Some of the teams have got some very, very amazing pump designs and engine designs that it was lovely to see. Like, we were sitting there and presentations were being given about each team's different, the way they're approaching the engine. And my goodness, some of them were beautiful.
Yeah.
So it'll be really, really nice to see everyone at the competition and see what happens.
And get to see the other successes of the other teams. I'm really looking forward to seeing their designs come off.
There is a prize, so we are still aiming to win.
We'll give it a shot.
But really, yeah, it is about sharing knowledge and just trying to boost the UK's propulsion abilities.
Who wins the prize? Is there is it who has the best design? Who has highest ISP?
I don't know.
There's if our head of propulsion was here,
He might know.
he might know. But there'll be a rubric as with all competitions of. I think a lot of marks are given for technical reports, aren't they?
Yeah, so technical reports, stability of your burn, how challenging was your design, and then probably post inspection of the engine. Did your engine actually hold up? Like maybe it had a good burn, but have you you've broken something in burning it? And team attitude, all those things kind of. But yeah, it's not about highest thrust or anything. You set yourself the challenge of what thrust you're trying to achieve. And what system you would like to run. Yeah.
They had a beautiful engine last year. Was it 50 newtons? Is that what it was? There was a tiny engine that they had. And,
yeah.
They won the award for the cutest shock diamonds. Was that Cran?
I think it was Cranfield. Yeah. Yeah. So it's not about highest ISP. It really is about that challenge of propulsion systems, and can you overcome that challenge? Thank you so much for your time.
Yeah. Thanks for your time. Lovely to speak to you.
Thank you for coming and answering my questions.
Try and inspire the next generation and see if we can convince you to come to Bristol.
Then bye.
Thanks.
See you. Have a nice one.
Bye.
Bye.